26th. Okay.
Okay, so it's the substitution.
Very good. Yes.
3x
Yes.
equals 5y plus 5,
Very good.
and 9x equals 2 minus 2y.
Okay. And we are asked to use substitution. Are you sure?
Well, yes, but it ends up being an odd substitution.
Right. So you're sure that we have to use substitution. Okay, then. In that case, let's use substitution. Okay, so I see, I'm looking first at both equations, and I realize that they cannot be simplified in any way, shape, or form. Okay, I will decide to solve the first equation by x, y, because it will have 3 in the denominator, and the 9 in front will eliminate that. Good. So from here, I will say x equals 5y plus 5 divided by 3. Is that okay so far? And now I will replace this in the second equation. So I have 9 over 1 multiplied by 5y plus 5 over 3 equals 2 minus 2y. And the fraction will go away. I simplify by 3. I never distribute before I simplify. Remember 3, if you come out of this class with 3 concepts, factor, simplify, and clean it up, you're way ahead. Okay, so I hope that at least that you would remember. Okay, now I have to distribute the 3. So I have 15y plus 15 equals 2 minus 2y. Then I move the y and I move the 15. So when I add 2, I have 17y. When I subtract 15, I have negative 13. Indeed, it's an ugly looking solution, but I have no choice. That's what it is. I will go back and check. There's no worries for now. Okay, I go back to here. I don't have to go back here. I go back here. So I have 3x equals 5 multiplied by negative 13 over 17 and plus 5. So I replaced y by what I just determined. Okay. I have to multiply 5 over 1 times negative 13 over 17. So this is negative, 65 divided by 17 plus 5. Okay, so far so good. Okay, I will multiply everything by 17. So 51x equals negative 65 plus 85. Let me check my numbers. Okay, this is correct. 35 and 3. Good. So now I have 51x equals 20. And finally, I get at x equals 20 over 51. My claim is 20 over 51 comma negative 13 over 17. Nobody knows whether this is true or not. Now, if you say I checked it's true, then I'll move on to the next problem. If not, I'll go back and check.
So about halfway through it, I realized I got the same answers.
Okay.
But it was the addition method.
Oh. Yeah.
The only reason I asked you to go over it is because it was just different than some of them where you ended up having to multiply twice. So the first
using elimination?
no,
Yeah,
using addition. So on the first equation,
elimination or addition are the same. So you're saying that using elimination or addition, they are the same methods. Addition or elimination are the same.
Yeah.
So you're saying that using addition or elimination, you had to multiply twice?
Yes, but remember I'm doing it out of the book because I wasn't here last week. So maybe it was
You don't have to do that. So do I have to check this, or is this the correct solution? Okay, then I don't have to go back and check. Okay, so now let me show the same problem with elimination. So we have 3x equals 5y plus 5, and 9x equals 2 minus 2y. Okay, so first of all, it has to be rearranged because y and x have to be on the same side, and the free terms on one side. So that will be my first step. So it's 3x minus 5y equals 5, and 9x plus 2y equals 2. And now I would like definitely to eliminate x, multiplying the first one by negative 3. So negative 9x and plus 15y equals negative 15, and then 9x plus 2y equals 2. 17y equals negative 13. So then y equals negative 13 over 17. Now, if you say, well, I really don't want to go back and replace y by a fraction, then I would have to agree you have to go back and now eliminate y in order to get x. I would never do that, though.
Okay. So that's exactly what happened.
There is no need for that. I think it's more complicated because you're starting from scratch now, and you go back to the original problem and you say, oh, now I need to eliminate y.
Mm-hmm.
And yes, and you will have to multiply both equations because negative 5 and 2 have a multiple of 10, so you have to create a negative 10 and a positive 10. You don't want to do that. There is no need for that. I'm not saying it's wrong. I'm saying it's way more work. What I would have done, I would have gone back to either one and plug it in.
Yeah.
So 3x minus 5 multiplied by negative 13 over 17 equals 5. And then you get exactly what I just got here. And you will get 20 over 51.
Okay.
I'm not saying one more time that it's wrong to go back and say, okay, now forget about the fact that I have y. Let me eliminate, forget about the fact that I have y, and let me eliminate y and get x. Very good question. Next question. Please.
Okay.
Put us on the right track.
4
Yes?
ln x
Yes?
plus 5
Yes?
ln y
Yes?
minus 6 ln z.
Very good. And we want to condense it.
Yes.
Good. So remember when we try to condense a log expression that has numbers in front of logs, that's my first step. I have to take those back where they came from. And where did they come from? From the power, right? So this 4 comes from the power of x. This 5 comes from the power of y, and this 6 comes from the power of z. That has to be the first mandatory step. So then I have natural log x to the 4th plus natural log y to the 5th minus natural log z to the 6th. After this, I realize that 2 of the logs have positive in front and 1 log has minus in front. These 2 expressions have to come from the top, and there has to be a product. And this one, because it has minus in front, has to come from the bottom. And it's done. So natural log x to the 4th, y to the 5th, over z to the 6th. Is this okay?
Yep.
Perfect. Next question. Anyone? Any questions on these? Anything else? If not, we'll pick problems from the book. Yes, please, Brendan.
Can you do one of those? I forgot what it's called. It's like that Greek symbol thing.
The sigma notation or the summation notation? Sigma notation or summation notation? Yes, awesome. And I also want to show you how to use the graphing calculator on it. I would have done that anyway, but thank you for asking. So these problems come from 8.1. If you have your book, you can choose. If you don't want to choose, I will choose. So page 752. Do I get to choose, or you want me? Yeah, okay, very good. So I can choose few problems here, not just one. Let's say 35. On page 752. So we have the sum from I equals 1 through 4 from -1/2 raised to I. Find each indicated sum. First, I would like to present it. Can anyone dictate, first of all, how many terms does this sum have? I don't know. When I is 1, I have the first term. When I is 2, I have the second term. When I is, I have the third term. When I is, I have the fourth term. Do I continue? No. From I equals 1 through 4. Good, so let's list them. So let's see them. What will be the first term? Not calculated, just for everyone to see what will be the first term.
-1/2 to the power of 1.
Good. Plus,
-1/2 squared
plus,
-1/2 cubed.
that's it. Now I would like to do this with the graphing calculator. Some calculators have this, some don't. If you go to math and scroll up to look at this.
It's neat to know the calculator could do
Very
that.
neat. Very neat. I agree. Okay, so from I can put I in there in the calculator. I have to put it x. So from x equals 1 through 4, and in parentheses, I have -0.5, and outside caret x. And it should give us the answer. I doubt.
Perhaps 1 over that?
That's what I wrote, -0.5.
No, I mean,
From I equals 1 through 4, -0.5 to x. Not possible.
maybe you have to write it as a fraction.
Maybe.
I got 1,024.
That's not possible, either one of them. So let's calculate by hand. There are only 4 terms. Something is wrong. Okay, it's not possible. So this is -1/2. This is +1/4. This is -1/8. And this is +1/16. All these numbers are smaller than 1. Right? So I can't have 4,096 or whatever we got. We have to fix that. Don't trust the calculator right now. So the least common denominator is definitely 16.
You should actually end up with 1/2.
Okay, so yeah. So the least common denominator is 16. So this is 8. So this is 4, and this is 2, and this is 1. So -8 plus 4 minus 2 and plus 1. So -8 minus 2 is -10. -10 plus 5 is -5. So this is -5/16. So we have to go back to the drawing board. Something is not right. Okay, let's see what it didn't like. But I don't want to spend too much time on this. Here's the second option. So the second option is, it may or may not work on my software here. But let me try this one more time, okay? Because it makes no sense. Something is flawed here. Okay, from x equals 1. Let me check one thing here. I want to change this into the sequence. Maybe that's what the problem was. It did completely something different. Okay. Okay, I'm going to clear this. I'm going to just come up with the previous entry. And if I don't get -5/16, I have to go back to the drawing board. Because it makes no sense. It makes no sense. Okay. So it's not that. Okay, let me try again. And then I'll show you the other method. But this is very convenient. I don't know why it's not working. Okay. X from Okay, what did I do now? Okay, x. Okay, 1. No, not y. Okay. Okay, because I changed it to sequence. Let's see what it does now. To 4. Okay, and this is negative 0.5. It's negative 1 over 2 raised to caret. Maybe I didn't put the caret. Maybe I need to put parentheses. And I need to put parentheses x. I always put parentheses. I didn't put it. Okay, yeah, because I changed it. Hold on. No, hold on. I have to go back to function. Okay.
Like that doesn't have to be y.
No, no, I mean, because of this sequence. Okay, I'm trying it again. Okay, x, 1, 4, in parentheses, negative 0.5, caret, in parentheses, x. That's probably why it didn't like it. I have no idea. This is totally wrong.
Mine, I'm putting the exact same thing in and coming up with 1024 every time.
Okay, so let's
Maybe for
do.
the top, set it to x equals 4. I don't know.
No.
Can't do that.
No.
Try that
Okay, so
way.
here's the other option. If it doesn't work on the software, I'll show you with a calculator. So second in catalog. Oh, it's working. Okay, second in catalog. Click on S. S is right here with the alpha and natural log. Okay, I have no idea. We need a new computer. Okay, so second in catalog. And when we click on alpha and S, enter, no, okay, second in catalog, I want to get to, okay, without the alpha, just it takes you, jumps to S, because I know I need the sum, SUM. So when you scroll down, or go to T and scroll up, whatever it's easier for you, sum, SUM. Although the math may have that already. Sum of the sequence, second in catalog again, press S again, it jumps you to S, and now SEQ. So what we have here is negative 0.5 raised to x. So in parentheses again, negative 0.5 in parentheses, caret, parentheses, x, close, comma, the sequence has x in it, x, comma, it starts with 1, comma, it ends with 4, comma, by 1 every step. So then I click a parenthesis for the sequence and the parenthesis for the sum. And when I click enter, I should get this. Otherwise, yes, because negative 5 divided by 16 is that number. There is no question that that's correct. Why with this software I get what I get, I don't know.
Maybe it's the difference between the.
Let me also try this with the sum. Okay, so x, 1, 4, a negative 0.5. Maybe I should put that in parentheses again. Let me try this. Maybe that's what it doesn't recognize something. So close the parenthesis, caret x, and then down parenthesis. Why doesn't, okay, never mind. Ah, so that's the problem. It didn't like it with the software because I did not put it in parentheses twice. Okay, fine, that's fine. So I go back to second and entry. That's what it didn't like. Makes sense or not, that's what it is. Okay, in parentheses, negative 0.5. Close the parenthesis, caret x. And
Oh,
go
they're like
outside,
that, yeah.
close
Power-
the parenthesis, and then delete everything else. Oh, it just deletes everything the long way.
Probably wants to get rid of that second x.
Yes, I'm trying to get there. Never mind. Okay, so math. Okay, yeah, right. That's not what I wanted. See how parentheses are so important? One time I didn't follow my heart and I messed it up. Okay, 4, and in parentheses again, negative 0.5 caret x. Okay, just give me the correct answer. Okay, it did. So that was the problem. So the syntax of the summation notation for the calculator, it's asking you to, in a big set of parentheses, you put inside everything, assuming whatever you need in there, parentheses. That's what the problem was. Did you get the same thing, Dallas?
Yes.
Okay, perfect. Brendan, is this something you had in mind? Something like this?
My calculator doesn't do that, though, so.
Oh, but it does the sum of the sequence. So the sum of the sequence should also be somewhere in math, maybe in numbers, no. Not in probability, that's for sure. No.
Maybe.
Maybe in stat. Let me check. Let me check the stat with math. Here it is. Okay, so you have the sum, which is 5 in math. So let me show you again. Second and list. Go to math. And you have the sum, SUM. It's number 5. Then go to second and list again, and go to math. And you see the sequence is right here in the operations sequence. And you have sum in the sequence right away. Okay, so in second and list, you will get SUM and SEQ very quickly. You don't have to scroll up and down to the catalog. Okay, so let's look at another problem. Let's say, for example, 45. If we did 45, then we'll choose another. They're asking us to present this using the summation notation. What do you think?
X equals 1 or whatever the variable is.
Okay, let's say j this time. We want j or k or I, doesn't matter. From I equals 1 through 11. From what?
2 to the power of j.
2 to the power of j. When j is 1, we get 2. When j is 2, we get 2 squared. When j is 3, we get 2 cubed. When so on and so forth, till the last one, 2 to the 11th. Is that okay? Good. We need other examples. You want to look at the factorial notation by any chance? Should we look at the factorial notation? Okay, very good. So let's do, let's say, let me make one up. Let's say we have 14 factorial times 2 factorial over 18 factorial. Okay. I'm going to multiply also by 20 factorial. Okay. So 14 factorial times 2 factorial times 20 factorial over 10 factorial. If I read it again, I'm going to add some. Okay, that's it. Promise. Okay, so I'm asked to simplify this. I would not put it in the graphing calculator. The numbers will be humongous. So here's what I would do. I see the 14 and the 10 being close and the 18 and 20 being close, and this doesn't mean anything really, it's just 2 times 1, right? So 14 and 10, I will present 14 factorial times 14 times 13 times 12 times 11 times 10 factorial. I'm going to stop at 10 factorial and write 10 factorial underneath. So these two are accounted for. The 2 is just 2 times 1. I can disregard the factorial. Multiplied by 20 and 18. 20 is the bigger of the two. So I'm going to say 20 times 19 times 18 factorial, and I will copy multiplied by 18 factorial. Why do I stop at 18 factorial? Because I see 18 factorial in the denominator. And now what will you think of doing? Now, Tom. Okay, you're canceling out 10 and 10 factorial, and you're canceling out 18 factorial and 18 factorial. And this is still going to be a huge number. I don't know if the calculator, I don't know how big it is, really. So let's give it a shot and see what we get. So 14, 13, 12, 11. 14 times 13 times 12.
960,960.
Yeah, I'm not going to, yes, but times 2. Did you multiply by the whole thing? Times 2 and times 20 and times 19?
Right.
Yes?
Times 18. 328 million. Huh. Neat. I got about twice that.
Okay, let me check. Maybe I made a mistake. 14, 13, 12, 11, and 2. Yes. And then 20.
19, 18.
Yes, let me check.
Wait a second.
And then 20 and then 19. And then I pressed enter. So I got 11,
Oh, you don't
18.
multiply by 18, right?
No, no. So 18,258,240. and 240. Good. Let's look at 51. Four plus 4 squared over 2 plus 4 cubed over 3 plus dot 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 plus 4 to the nth power divided by n. And they want us to do the same thing. They want us to come up with the summation notation for this. Not Tom.
That last one's 4 to the what power?
N. N is the last. Good. So since all of them are fractions, including the first one, I will expect you to give me a fraction. Let's start with which part? You want the numerator or the denominator?
Numerator.
Okay.
4.
To the?
N.
I can't. I cannot use n. N has to be the upper limit. So I will say k equals 1. So it's going to be 4 raised to k. When k is 1, I get this. When k is 2, I get this. When k is 3, I get this. When k is n, finally, I get this. Is that okay? Good. Now the denominator, please.
Okay.
Thank you. So let's check again. When k is 1, 4 over 1. When k is 2, 4 squared over 2. When k is 3, 4 cubed over 3, and so on and so forth. When k is n, 4 to the nth over n. Is that okay, everyone? Yes? Okay. Do we need more from this section, from 8.1? Anything else? Tell us you have something else for us?
I just wanted you
Yes, please.
to remind me of the correct order of transformations.
Yes, the order of transformations is the order of operations. So for example, if you give me a function like this, negative 3 times e to x plus 2 and minus 5. There are several transformations in this, right? Okay. Now, I have to present the base function, and the base function is definitely e to the x. That's the core function used here, or the base function. Okay. Now, here's how I think. If you give me this function and you ask me to evaluate it for x equals 2, what operation will I perform first? And the answer is 2 plus 2. So that's the first transformation. Then I will get this function, which is the base function. I can't do anything. When I'm done with this number, the next transformation is multiplication by 3. You could say, yes, but when I evaluate, I don't really multiply by 3 first and then by negative 1. I multiply directly by negative 3. And I will have to agree, but there are two transformations in there. That's why when we present the transformations, I have to separate the negative 3 from the 3 from the negative 1. So this will be my first operation. Then will be multiplication by 3, which is a vertical stretching. This will be x plus 2, which moves the graph to your left, 2. Then I will multiply by 3, which is a vertical stretching by a factor of 3. Then I will reflect. That's what the minus will say. And then bring down everything negative 5. And this is how I will evaluate the function. First, I perform this. Then I get a number. Then I multiply by 3. Then I multiply by negative 1. And then I subtract 5. So that's why you don't have to memorize this. You will just think in terms of evaluating. Is that better?
Yeah. I just need to memorize which is which.
Yes. Okay. So in the first step, I will say e to x plus 2, which is left 2. In step 2, I will say 3, e to x plus 2, which is a vertical stretch by a factor of 3. Then in 3, I will say negative 3 e to x plus 2, which is reflect with respect to the x-axis. And number 4, negative 3 e to x plus 2 minus 5, which is down 5. So remember, when you change x, you're doing this. When you change y, you're doing this. Or vertical stretching, or horizontal stretching, or shrinking. So when you change x, everything happens on the x-axis. When you change y, everything happens on the y-axis. So how do I know what I changed from here? It's clear. I changed x into x plus 2. How do I know what I changed from here? It's clear. X doesn't change. It's still x plus 2. So this is outside. So that's what it's a vertical stretching. It depends on y. Now what do I change from here? I change the y from positive to negative. That's why it's a reflection. And what happens from here? I bring everything down, and bringing everything down means I'm changing y. Somewhat better? Okay, next question. Very good questions, really, very good. Next, anything else? Ashley, are you okay? Any questions for us? Anyone? What would you like me to continue with? Ryan, do you have any questions from that form?
Yes?
Yes, just the first 4 pages.
Okay. I was looking through it.
Okay, if you have anything, let me know. What would you like me to continue? If you don't have other questions for test 3, I would like to review for the final exam. So what would you like me to do? We have to choose something. If not, I will. Say it again.
I'm just going to look at test 2 and see what I got wrong with test 2.
Okay, very good. It's a good plan. Do we have anything else from test 3? For example, do we need to look at another Gauss-Jordan elimination? Do we need to graph? Here's my list. Okay, so these are the problems from 4.1 through 4.5, and these are the problems from all the other sections. 5.1, 6.1, 5.4, 5.5, and 8.1. So what would you like us to go back to? I can't stand and smile nicely. I have to do something.
I have a question.
Please.
So number 6 on this. I already
6.
have the answer, but my question is more or less a word problem. Which particular, it says use stray cat population grows exponentially. Both functions are exponential. So does it matter which one we use?
I don't know. Let me take a look for a second. You said numbers.
It doesn't give a semi-annual, monthly, continuous. It just says it grows exponentially.
This one, the stray cat population? Yes?
Yeah.
Okay, so let's read it. Do you have this form, everyone? Anyone else? Okay, here it is. Good. So it grows exponentially in a small town. In 1999, the town had 30. And the relative growth rate was 15% per year. Find a function that models the stray cat population after t years. Use the notation a of t. Okay, in that case, a of t equals a0 e to rt. I know that this is the only option because it's the population exponential growth. Okay?
Just because it's exponential growth? Like,
Because
what key
populations,
population?
bacteria, bats, rats, fish, people, they all grow exponentially. Yeah. It could be an exponential growth with a base greater than 1, or it could be with a base less than 1. For example, till about a couple of years ago, population of Germany was going down, was decreasing. Yep. So that was a population that was not growing exponentially. Good. So we know that, okay, is there anything else? No, for now. So the problem was asking us to find the function. So by finding the function, remember, this is our y value. This is the function. And this is the independent variable. I do have the rate, which is 0.15. The only thing I don't have is a0. But it is assumed that since we are given this information, they are not looking at the stray cat population beyond or before 1999. So this is our a0. So this is our 30. So a of t equals 30 e to 0.15 t. In part B, we're asked to find the projected population after 4 years. What are we going to do here? How do I find the projected, if the model still holds? I don't know.
A of 4.
Yes, so I have to find a of 4. I will punch it in the calculator. And in part C, so this was part A, this was part B, and this was part C, find the number of years required for the stray cat population to reach 500. So how will I address the third question? What do I have to write? Not Tom. Oh, he's asleep anyway. So we're asked, find the number of years required for the stray cat population to reach 500. What will I have to write? Say it again. Just dictate, and I'll write it. Yes. Exactly. Awesome. So let's plug in 4 first, finish that up, and then we'll solve the equation. Awesome. Well done. So in y, no, I only have one variable, one request, in other words. 30 multiplied by e2, in parentheses, 0.15 multiplied by 4 years, close the parenthesis. I can say 55 because 54.6 cats does not mean 55, so I'm going to say 54. Good. Now, we have an equation to solve. What type of equation is it? That's my first question to myself, so I know what I have to do. First, I have to identify it correctly. So what type of equation is it?
Exponential.
Thank you. And how do I solve it? What would be the first step?
Clean it up.
Thank you. How do I do that?
Start by dividing by 30.
Thank you. So it's 50 divided by 3 equals e to 0.15t. Now it's ready for now it is ready for
You have to put ln instead of-
I apply natural log to both sides. Very good. Awesome. The left-hand side is natural log 50 over 3. And the right-hand side is
1 to the 0.15t.
0.15t. Very good. Awesome. Good. Final step.
divide by 0.15.
Awesome. Thank you. Well done. So let's put in the graphing calculator. Natural log 50 divided by 3. And divide everything by 0.15. And we got 18.7, so approximately,
18 and 3/4.
yeah, approximately 19 years, which means 19 years since what was it? 1999. Yes.
So about nowish. Recently.
Jason, is this okay?
Oh, I was good on that part.
Say it again.
I was good on that. I was already done that.
Okay, good.
I was just curious of which one to use.
Yes, yes. The models will be given to you. This was a 151 class.
Where the models aren't.
No, they have more work in 151. Yes. Okay, so now do I choose? Do you have anything else for me? Eddie, you have anything for me?
No, okay. Which one are you on right now?
We worked on problem 6 from the yellow form.
Thank you.
You're welcome. I saw you at the Rundle Mills yesterday.
Oh, okay.
No, I was not following you around. I teach there Mondays and Wednesdays. I said, that's Eddie.
Wednesday.
Okay.
You teach Calc 2, right?
Yes.
Do you know a guy named Lawrence?
Student?
Yeah.
Okay, so let's look at section 5.1. I would like to work on a word problem from there. Yes. Problems 55 and 56 on page 556. So since you don't have a lot of questions today, it means that I can sleep tight over the weekend because everyone is going to get a very good grade on this test. Yes?
Yeah.
Okay, because now I have more students in the room. I wrote the test. It has 23 questions. And my math lab says that you need 46 minutes to finish the test. You have 2 hours or more. So all problems come from your book. All problems come from my math lab. So if you do all the problems we did in class and the ones in my math lab and the ones recommended, next semester I'll invite you to teach this class. Please. Okay? I want very good grades. Okay. The figure shows the graphs of the cost and revenue functions. So I'm going to copy the picture here. So the revenue is this, R of x, and it's given to us is 50x. And the cost function is this. And it's given to us as 10,000 plus 30x. 30x. And here's the question. Question 55. How many radios? Okay, I'm sorry, I didn't finish reading. The figure shows the graphs of the cost and revenue functions for a company that manufactures and sells small radios. Okay. Use the information in the figure to solve exercises 55 through 60. Okay. How many radios must be produced and sold for the company to break even? So what does that mean? When a company breaks even, what does that mean?
When they paid off their initial investment?
No.
Well,
When money coming in is exactly the same with money going out.
Right.
In other words, money coming in is revenue.
no profit.
No profit. Very good. Awesome. So when the revenue equals the cost, that is a break even. I'm sure you've seen a problem like this in my math lab already. Or profit of X equals 0. Good. So how do I proceed? Can anyone tell us how to continue here? Can anyone dictate what to do next?
That both equations equal to 0?
No? I already have the equation here. You just have to tell me what to do.
Revenue is 0? Or
I already have the equation here. So what do I have to write? Anyone, please.
You're just setting the two equations equal to each other. So
Two expressions, yes.
I can't see the top one. Is it
50x.
50x equals 10,000 plus 30x.
Good. That's all I have to do. What type of equation is it? How do I solve it?
Linear.
Good. I'm moving 30 to the other side. 20x equals 10,000. So then x equals 500 units. So this was problem 55. Problem 56. More than how many radios must be produced and sold for the company to have a profit? More than how many?
one, that's for sure.
No, because they break even at 500.
Well, technically, that's more than 1. I'm just being facetious right now.
Okay, very good. Okay, so more than what?
What was the question?
Okay, let's read it again. More than how many radios must be produced and sold for the company to have a profit?
Like the break even at 500, you can sell 501.
More than 501. 501 or more. Okay, more than, I would say 500, or if you want to say greater than or equal to 501. One or the other. Very good. Any questions? Is there any particular topic for test 3 that you would like to go back and review? If not, I would like Ryan to give us a question from test 2. If you want, if you found something for us.
I think I know my flaws for test 2.
Okay. That's a huge. Okay, so do we have anything else for test 3?
I don't.
Okay, so let me go through the topics one more time, and if you agree, we move on to back to test 2. If you say no, we should still stay on this, we'll stay on this. So 4.1 exponential functions, 4.2 log functions, 4.3 properties of the log, 4.4 equations, exponential and logarithmic equations, and 4.5 word problems. Any of the topics? Any of these topics you would like to review? Okay. Then 5.1, systems of linear equations, substitution and elimination. 6.1, Gauss-Jordan method. 5.4, systems, nonlinear systems of equations.
Inequalities, right?
5.5, nonlinear systems of inequalities, correct. And the last one, what we reviewed today, sequences. Any of the topics listed you would like to go back and review? Any questions? Okay then, let's go back to test 2. Brian, you would like to start with a question or not? I don't want to put you on the spot.
No, it's fine. I struggled with synthetic division.
Very good. Very good. So let's look at that. Long division. Long division and synthetic division. Good. Okay, this is in chapter 3. I'm looking at the chapter test. Chapter test. On page 416. I'm trying to find a problem, or I can make one up. I will have to make one up or go back